September on the Front Range of Colorado usually consists of dry, warm days and clear, cool nights. September 2013 brings up very different memories. Record-breaking heat abruptly changed to days of relentless rainfall that the National Weather Service has described as being of biblical proportions. This storm caused flooding and destruction that had not been seen in the region for several decades. While extreme rainfall and flash flooding from convective thunderstorms with much higher rainfall rates is not uncommon, the characteristics of the storm that caused the September 2013 floods were very unique for this area, as it was more tropical in nature, and it is much harder for the atmosphere to produce near constant rain for several days over several hundred miles, especially in the semi-arid high plains and foothills. The week before this historic flooding event, there was an upper-level high-pressure ridge across the western United States that caused extreme heat on the Front Range, and 3 daily temperature records were tied or broken. This high-pressure blocking ridge then moved north and east over the Canadian Rockies, while a near-stationary upper-level weak low-pressure cyclone set up in the southwestern United States. The counterclockwise circulation of this weak low-pressure cyclone pulled monsoonal moisture from the Pacific Ocean and brought unusually high moisture to northern Colorado. The main jet stream was located well north in Canada, which allowed this pattern to stay in place for almost a week. While the large-scale upper-level atmospheric features created an environment to allow persistent wet conditions from southern Wyoming to central New Mexico, low-level, smaller-scale atmospheric processes were responsible for localizing heavy rainfall along the Front Range. There was a cyclonic mesoscale circulation causing east-to-west upslope flow that pulled moist air from the Gulf of Mexico to the foothills. The synergy of these meteorological conditions resulted in record-breaking precipitable water in the atmosphere. The Rocky Mountains forced this unusually moist air to rise. This ascent was enhanced by diverging winds aloft and caused significant amounts of precipitation to form. The meteorological conditions also did not allow the storms to move off the foothills, and instead they lingered over the Front Range urban corridor, allowing storm cells to regenerate over the same location and record-breaking rainfall to occur. In a little less than a week, the hardest-hit areas of Boulder and Larimer County met or exceeded their annual average rainfall when rain started falling on September 9th and lasted until September 15th. There was nearly continuous rainfall from September 9th until September 13th, with 2 pulses of intense rainfall embedded in the steadier rainfall. The majority of the rainfall occurred in a 36-hour period on September 11th and 12th. The first period of intense rainfall occurred on the evening of September 11th, lasted for 12.5 hours, and saw rainfall rates between 2 to 2.75 inches per hour. The second period of intense rainfall occurred on the evening of September 12th, lasted 8 hours, and saw rates between 1.5 to 2.4 inches per hour. The heavy rainfall cleared briefly in the evening of September 13th until the morning of September 14th, only to return later that evening, and one final surge of moisture on September 15th saw widespread rainfall rates between 1 to 2 inches per hour. This prolonged rainfall led to several precipitation records being broken. A new daily rainfall record was set for the entire state of Colorado when a gauge near Colorado Springs measured 11.85 inches for a 24-hour period on September 12th. Daily, weekly, and monthly rainfall records were all set within the city of Boulder, nearly double the previous records. Studies have shown that the amount of rainfall that occurred in Boulder County has only a 0.1% probability of occurring in any given year. Observed rainfall far exceeded forecasters' expectations, and 3 of the top 10 largest one-day rainfall totals ever recorded in state history are now associated with this September 2013 storm. This historic rainfall event led to massive and destructive flooding, and during the event, 65 flash flood warnings were issued. Flooding occurred over a 1,918 square mile area. Over 19,000 people were forced to leave their homes, and 8 people lost their lives as a result of the storm. The torrential rainfall that occurred on September 11th and 12th was falling on already saturated ground, and over the 36-hour period that saw the heaviest rainfall rates, 1,138 debris flows were triggered and were responsible for 3 of the 8 fatalities. The widespread flooding and debris flows also caused extensive damage to buildings, roads, and other infrastructure, causing over $4 billion in damage. Statewide, over 200 miles of highways and 50 major bridges were damaged or destroyed. Over 2,000 houses were destroyed and another 26,000 were damaged. Destroyed bridges and highways left several mountain towns completely cut off and hundreds of people had to be rescued by helicopter. The September 2013 floods also transcended timescales. They started as short-term flash floods cascading violently down the mountain streams and then spilled into the rivers on the plains, where communities remained flooded for days after the rainfall ceased. The floodwaters reached western Nebraska, where almost 2 weeks later, the water in the South Platte River finally returned to below flood stage levels. None of the cities or towns located along the Front Range of Colorado were fully prepared for a week of extreme rainfall. However, Colorado's history of flash flooding meant that modern warning systems and floodplain management helped to minimize losses and streamline emergency response. Despite many flood control structures performing according to their design, many vulnerabilities to the flood infrastructure were also exposed during the September 2013 Colorado flood. During the rebuilding process, stronger, smarter infrastructure was designed to withstand water. Floodplains were redrawn, and city planners turned hard-hit, low-lying neighborhoods into green spaces in an effort to minimize damages in future floods. Rebuilding from this historic storm was a long, slow process, and some of the hardest-hit mountain roadways did not reopen until 3 years later, and US 34 between Loveland, Estes Park, and Rocky Mountain National Park was the last stretch of highway to be reconstructed. It finally reopened in 2018, nearly 5 years after the storm. Engineers redesigned, or in some cases even moved, roadways to better deflect and avoid floodwater and washouts. Streams and rivers will go where they want to, not where we tell them. Flooding remains a crucial issue on the Colorado Front Range, and the lessons learned and improvements made as a result of this historic storm could prove instrumental in mitigating flood damage and fatalities when the next major flood hits.